Near-Earth objects, NEOs, are comets and asteroids that have been nudged by the gravitational attraction of nearby planets into orbits that allow them to enter the Earth's neighborhood. Composed mostly of water ice with embedded dust particles, comets originally formed in the cold outer planetary system, while most of the rocky asteroids formed in the warmer inner solar system between the orbits of Mars and Jupiter. The scientific interest in comets and asteroids is due largely to their status as the relatively unchanged remnant debris from the solar system formation process some 4.6 billion years ago. The giant outer planets, Jupiter, Saturn, Uranus, and Neptune, formed from an agglomeration of billions of comets, and the leftover bits and pieces from this formation process are the comets we see today. Likewise, today's asteroids are the bits and pieces left over from the initial agglomeration of the inner planets that include Mercury, Venus, Earth, and Mars. NEOs are asteroids and comets with perihelion distance q less than 1.3 Armstrong units. The vast majority of NEOs are asteroids, referred to as near-Earth asteroids, NEAs. NEAs are divided into groups as Hetaira, Haten, Apollo and Amor, according to their perihelion distance, q, aphelion distance, q, and their semi-major axes, a. Potentially hazardous asteroids, FOAs, are currently defined based on parameters that measure the asteroid's potential to make threatening close approaches to the Earth. On a daily basis, about 100 tons of interplanetary material drifts down to the Earth's surface. The vast majority of the larger interplanetary material that reaches the Earth's surface originates as the collision fragments of asteroids that have run into one another some eons ago. Because of the ongoing search efforts to find nearly all the large NEOs, objects will occasionally be found to be on very close Earth approaching trajectories. One of the techniques suggested for deflecting an asteroid includes nuclear fusion weapons set off above the surface to slightly change the asteroid's velocity without fracturing it. High-speed neutrons from the explosion would irradiate a shell of material on the surface of the asteroid facing the explosion. 2020 was basically a disaster movie, and 2021 isn't looking much better. As if that wasn't dystopian enough, there is now a ginormous asteroid that will be passing uncomfortably close, uncomfortably soon. Asteroid 2001 fo32 is going to be zooming past Earth on March 21st, but wait. An asteroid as white as the Golden Gate Bridge is long will hurtle past Earth next month. This asteroid will make a flyby at almost 770,000 miles per hour. That's 21 miles a second. But although it will be the biggest and speediest asteroid to fly by our planet this year, there's no reason to panic. The space rock, officially called 231,937 2001 fo32, is about 0.5 to 1 mile in diameter and will come within 1.25 million miles of Earth at 11:03 a.m. Eastern Standard Time, 16:03 GMT, on March 21st, close enough and large enough to be classified as potentially hazardous, according to a database published by NASA's Jet Propulsion Laboratory. An asteroid is designated as potentially hazardous when its orbit intersects with Earth's at a distance of no more than about 4.65 million miles, and it is bigger than about 500 feet in diameter. Small asteroids pass between Earth and the Moon several times a month, and their fragments enter and break up in Earth's atmosphere almost daily. Telescopes in New Mexico that are part of the Lincoln Near-Earth Asteroid Research Linear program detected the asteroid on March 23, 2001, according to Earthsky. Scientists used these observations to calculate the asteroid's orbit and determine how close the space rock will come to Earth when it whizzes by at almost 77,000 miles per hour. No known asteroid poses a significant risk to Earth for the next 100 years. The current biggest known threat is an asteroid called 410777 2009 FD, which has less than 0.2% chance of hitting Earth in 2185. NASA is studying methods of deflecting asteroids that do end up on a collision course with Earth, such as by using the gravity of a flying spacecraft to slowly pull asteroids off their trajectory to a safe distance. If you have a telescope, dust it off. It will get brighter and more visible to telescopes on Earth the closer it gets. Astronomers will then have the chance to observe it in the optical and infrared wavelengths, which will give them an idea what its shape and surface look like. 2001 fo32's orbit has been studied long enough for NASA to be sure it won't end up giving our planet a punch in the face. It is in a highly elliptical orbit around the Sun and passes our star every 810 days, so a year on this asteroid is a little over twice what it is over here. Its size was determined by how bright it appears, which depends on the way it reflects light. It may be larger than 97% of asteroids, but remember that many asteroids and meteorites are small enough to burn up or at least break up in the atmosphere if they do come hurtling down to Earth. Even at a size that would make the Golden Gate Bridge shudder, it is still nothing compared to the really large asteroids lurking in the dark. We won't even have to worry about any of those for at least the next 100 years. Anyhow, no one should be overly concerned about an Earth impact of an asteroid or comet. The threat to any one person from auto accidents, disease, other natural disasters and a variety of other problems is much higher than the threat from NEOs. Over long periods of time, however, the chances of the Earth being impacted are not negligible, so that some form of NEO insurance is warranted. At the moment, our best insurance rests with the NEO scientists and their efforts to first find these objects and then track their motions into the future. We need to first find them, then keep an eye on them,